Okay, so we have our next video in our nuclear unit. So this video is going to cover half-life. I don't expect it to be super long, but we're going to go through a couple of different example problems and kind of what you should be expecting whenever you're doing a half-life problem. Okay, so first you want to know the definition of half-life. So what exactly is half-life? Okay, so half-life is the time that's required for half of the atoms of a radioactive nuclide to decay. Okay, so what I mean by that is, say, for example, and kind of just put something up here. So let's say that I start with 100 grams of something. Okay, after one half-life, I should have half of it. Okay, half of my atoms are going to decay, so now I would have 50 grams. So after two half-lives, I'm going to half it again, so I have 25 grams. After three half-lives, I have 12.5. So I'm just taking half at each half-life. Okay, after that, I have 6.25, and so on, so on, so on. Okay, so that's what I'm talking about based on that definition there. So this right here says that the half-life for a given isotope is always the same. Okay, so if I give you that the half-life of carbon-14 is 5,730 years, then that is always the half-life for carbon-14. However, it will differ if we start talking about a different radioactive nuclide or a different isotope. It's not gonna depend at all on how much I have or how long they've been sitting around. That time is always going to be the same. Now for a formula, okay, so for a half-life formula, we're going to say that this is going to be our formula. A equals A sub O, okay, times 1/2 to the n power. Okay, so we're going to say that when doing this, that A is going to be your final amount. Okay, A sub O is your initial amount. Okay, and then N is your number of half-lives. Now here's where I kind of want you to kind of take a step back a little bit, and here's what I'm seeing tons of when we're working these problems, is that where it says number of half-lives and where that n exponent is right there, people are wanting to put in whatever the half-life is. So if they say the half-life is 13 days, people are wanting to put 13 there. That's not what you put there. Alright, that's not what you put there. You put the number of half-lives. So first we have to determine how many half-lives there are. Alright, so don't try to skip steps. Don't try to make these problems harder than they are. They're not that bad. Okay, so let's move on. So if I'm solving a half-life problem, so first let's determine how to find the number of half-lives, how to find n. Alright, in this first thing that I have here, they say how many half-lives have passed after 45 days if a nuclide has a given half-life of 9 days. So we can actually kind of do dimensional analysis, which I know is not your favorite word, but we can use dimensional analysis. We can use it pretty easily here. So my number of half-lives, or n, is going to equal the time elapsed. So I'm going to start with whatever time elapsed I have, alright, times 1 half-life. And then in bottom, you're going to put whatever the half-life is. So what is the half-life? How many years or days or months or whatever given time you have is equal to 1 half-life. So 1 half-life equals 9 days. That's something that they give us in this problem. Notice how my units cancel and I'm left with half-lives. Okay, so multiply across the top, so that's going to be 45. Divide by bottom, okay, and 45 divided by 9 is equal to 5. So I have 5 half-lives. Okay, so this right here is what I'm going to plug into n. So many people want to plug in this 9. You put that in, you're wrong. Wrong. Alright, don't plug it in. Okay, if you have not been given the length of time, then first you have to determine it. So you might see a problem that tells you something that for a time, it might say how many, or it's not going to obviously ask you this type of question on the test, but it might give, instead of giving you, hey, 45 days passed, or hey, 20 hours passed, you might actually have to determine how much time has passed. Okay, so in that case, just know that, if you start at 9 a.m. on a Tuesday and you go to 11 a.m. on a Wednesday, well, that's 26 hours. Okay, 9 a.m. to 9 a.m. on Tuesday to 9 a.m. on Wednesday is 24 hours, and then you go 2 hours past that to the 11 hours. So I just kind of wanted to throw that out there because that's something that's possible that you might see, and I don't want that to trip you up when the point of a problem is understanding the half-life and how to figure out half-lives. Okay, let's move on. So here's the problem. Okay, so when we're doing half-life problems, we're going to multiply the amount of the substance by half to the n power, so that's just using that formula that I gave you. Here's an example. Polonium-210 decays with a half-life of 138.4 days. How many milligrams remain after 415.2 days if you start with 2 milligrams of polonium-210? Alright, so this isn't too bad. The first thing you want to do is determine how many half-lives do you have? Alright, well, how many half-lives do I have in this problem? Let's figure that out. No! Alright, so how many half-lives do you have? Well, you're going to start by saying, well, what is the time? So n, my number of half-lives, is going to be this that they give me, the amount of time that has elapsed, okay, divided by however long the given time is for a half-life. Okay, so 415.2 divided by 138.4. Okay, so that's when you want to kind of pull out a calculator, and you should get 3. Okay, so if you get a calculator, you'll have 3 half-lives there. So n equals 3. So I have my formula for half-lives. Okay, and we know that this n is now 3. So if I'm trying to find my final amount here, the only other thing I don't know or that I need to plug in is my initial amount. Okay, so what is my initial amount? Grr. Okay. What is my initial amount? They give me that my initial amount here, they tell me it's 2 milligrams. So I'm going to say 2 milligrams is my A sub O. So when I'm plugging all this in my formula, I'm going to have this plugged into my A sub O, okay, into my initial amount times 1/2 to the third power. Okay, I can plug this all in my calculator and I can figure out what it is. You really shouldn't need a calculator for this. Okay, 1/2 to the third power is 1/2 times 1/2 times 1/2. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Okay, so I have 1/8 times 2. Okay, and 1/8 times 2 is going to be 2/8, which is equal to 1/4 if you reduce, right, which is equal to 0.25. And like I said, you should be able to just plug that into your calculator and be fine, but really you don't necessarily need a calculator on that one, so I wouldn't waste my time doing that. I know in class I told y'all that there is, that you can kind of handle this a little bit differently. Now I do want you to be able to use this formula because there are times that you don't have whole numbers for your half-lives, so you can't really do it any other way. So I'd rather you use this formula right here than really trying to go step by step and count off the half-lives like I kind of did in the first slide that we did. Okay, I believe we have one more example to work through. It's just very similar to the last problem. First thing that we want to do is what? Think to yourself, give you 5 seconds there. Determine my number of half-lives. That should be my first step, okay? So when determining my number of half-lives, you know, how long did it go? Well, it went for 104.7 minutes. Okay, I'm going to put down here however long my half-life is. Okay, and up here I'm going to put 1 half-life, just like I did in the last set of problems there. What's 104.7 divided by 10.47? Well, you should get 10. So I have 10 half-lives. Okay, so now I've got to plug everything into my formula. Okay, so we know that A sub O, or my initial amount, is 10 milligrams. Okay, so that's going to be 10 milligrams. And we already have the value of 1/2 here. And 1/2 to the 10 half-lives. No. Okay, 1/2 to the 10 half-lives. So that's kind of a reason to have your calculator, and let me jump out just really quick and do this. So obviously, sorry, I had to jump out. I can just keep doing 2 times 2 times 2 times 2 10 times, or 1/2 times 1/2 times 1/2 10 times, and I will get the answer. But that's when I'm saying that a calculator is much more beneficial to you, because you're going to end up with this right here being 0.000976. Okay, so obviously that's not what you're probably going to want to write out. So if I multiply that by 10, then I'm left with an answer, or a final amount after after 10 half-lives. Okay, final amount after 10 half-lives of 9.77 times 10 to the negative 3 milligrams. So if I take half of 10 milligrams 10 times, then this is the answer that I end up getting. And that one's a little bit tougher. You just have to understand how to use your calculator a little bit better. But they're not that bad. You know, these problems aren't that bad, and kind of just a hint for the test. I mean, the problem's actually probably a little bit easier than this one. You might want to just look at your worksheet that we did, or practice problems that we did that I put on your review for half-life. There was one on there where you didn't have a full half-life. Okay, so I think you had about 3/4 of a half-life, and in that case you just had to put that into this right here. And I don't have an example like that on this video, but I hope that you watched both of these videos for this unit, and I hope that they were helpful. 2 things that I didn't include on the videos that you are responsible for. You are responsible for fusion and fission. So fusion and fission, fusion and fission, fusion and fission. Okay, fission, remember that's the splitting of the nucleus. Fusion, that's the combining of 2 nuclei. Alright, good luck!